All right, here's the final video on this series. Here's a legacy from something. So it's the same what we've been doing, except there's some breaks in this line. It could be a multitude of breaks, and I'm going to show you how to solve that. And no videos, there's nothing else to show you. That's the last one. Center of gravity out. That'll be a next one. If I do some more videos, I'll probably do that one next. Maybe save a life. All right, so here's the problem. The 5,983 is a pretty small area here, so just because it keeps the number smaller. So let's take a look. I think we have to zoom out a little bit. Okay, so there's a deal. It's called the shoelace method. Let's bring it, drag it. I'm just going to copy it over here. So let's take a look at this now. So the initial point, coordinates of point 1, we'll call this 1, 2, 3, 4, 5, 6, 0, 0, 70.97, 0, northing and easting, 80.47, 2612. Then it goes all the way around 29.28, and then easting at 109.30. And then what you do is you take the last point and put it here. So number 1 point is here and here. And then the quantities that are in the direction you do the multiplication here is 0 times 0, 70.97 times 26.6. So let's zoom out back. Let's take a look back over here and show you how those numbers get plugged in. So we have 0 times 0, obviously. This is the red. I don't know why that's orange. And then 70.97 times 2612. That's the first one that actually has an amount. 0, 0 is nothing, right? And then the last one, so there's 1, 2, 3 with values, 4 with values. The last one is the 109.30, so it would be 80.72. And then the last one here is 29.28 times 0, which is 0, so I just left it out. Then we have blue, so we have this times 0, 80.47 times 0, 64.16 times 26 is the first one we have. And then with the last one is 29.28 times 85. And then the last one here would be 0 again. So we've completed the loop. Now what you do is you take these, pardon the interruption. So what we do with these two groups is we add all of the results up. 1853.74 plus, and we get 19,354. And then this one we add it up to, and that's what we get. And then what we do is we take this one and subtract this one. So 19,353 minus 7,387 equals, and that's our total, right? So then divide that by 2 or multiply it by a half, and you'll get 5,983, and that's the total area. And we're going to divide that in half to get half the area for our solution for our parallel offset. So it's 2991, and that should look familiar. 2991, that's the area that we end up with for this. Now we're looking for the parallel offset distance. So there's a lot of steps, but I'm going to try to go kind of fast. But so what we do is we have a rectangle here. I'm going to just do it in purple. So this is we're going to do this times x, and that's going to give us the area for this rectangle up to this line here. So actually it's in green. No, it's in red. So we do this, and then that's the rectangle. So this triangle is added to it. this triangle here is subtracted from it. So we have here is 90 degrees, I'm sorry, 110 degrees minus 90, right? So we end up with positive 20. Triangle 1 is 1/2 of 26, and we have this dimension. We don't have to calculate this. I'm skipping a little bit, but let me finish with my thought here. So we're just going to solve for this area. The first step, if what we're looking for is bigger or smaller, depends on whether we continue or we go back and find the parallel offset distance over here, but it's bigger. So we're going to take, we have the 9.51, and we have this dimension. It's given because we have the 2612 off of the 0 line for the 0 easting, and we end up with 2612. So it's just straight multiplication. We end up with 124.07 positive. Over here, we know that this is 15 degrees, so we got to do a little bit of the trickery here, the substitution. So it would be y over x, and tangent of 15, we already know it's 15 here, would be y over x, and then we can solve for y, and it becomes tangent of 15 times x, and then we have this, so tangent of 15 times 2612, right? Will give us the, and then multiply that by 1/2, and we get the 91.405, and that's negative, right? Because it's coming out of that triangle there, and I didn't put that in. Let's do that. Should have been just at negative 15 degrees, but we know what we're doing here. So then the rectangle is 70.97 times 26.12. And we have that there, and we end up with that rectangle. So we're going to take the triangle 1, which is positive, and then we're going to have the triangle here, down here, which is negative, and the area of this rectangle. And I'm going to change that right now, just because if I ever come back to it, it's going to be negative 15. All right, and then the answer here is negative 91. So these we should add all of them together, and you end up with 1886. So you're just going to write that down. And pretty much the same thing we're going to do here. We're just going to take that rectangle. We already know the distance here, 13.69. We know that. Now this is going to be green. We're going to end up doing subtracting both of those. Right, this rectangle here, this is coming off of it, and this is getting subtracted off of it too. So both of those are negative. So 1369, 1632, and that ends up being 111. And let's put a negative on there. And then this one, the rectangle, just got to do the math, right? So we know that the coordinate here less, that you got to do a calculation here. So I think I just did it, multiplied it. We know the height of this one is 7, is a tangent of 15 times this. And then this would be plus tangent of 15 times 13.69. Probably what, somehow what went there for the height, right? 3.66. I'm not seeing it. Negative. That was the negative there too, right? All right, so we're getting a negative triangle, positive rectangle, negative triangle. We add all those up and we get 869.15. That's this area, and if we add those two together, we end up with 2755, which is still lower. I'm sorry, 2991. So we're still less. So we're going to take 2991, subtract those two, which add up to 2755, and we end up with 236.19. And that's the area that we want to solve for, really. Those are just steps, and I could have just told you and you would have known, but I wanted to go through the steps anyway because that's what I do. We're going to take this this area, and then we're going to create a quadratic equation. We know this is 20 degrees. We know that's 15 degrees, so this is a positive. So we do 1/2 a tangent of 20 times x squared, because we don't know this one, right? And then plus 1/2 a tangent of negative 15 times x squared plus 53.49. We just calculated that. Oh, that's why I added those two. That's why I took this one and then did the step here for this step so that I could calculate that 53.49. So 0, this minus this distance here, those two added together. You could have just done one altogether. That'll give us the 53.49 times x minus 236, because we know this area is 236. So instead of equal 236, we bring it to this side. And now we have the polynomial that we can, trinomial that we can use in the quadratic form. And I think I'm going to take this 53.49, 15, and 20. 53.49. So the height is 53.49. The first angle is positive 20. So I think it was 110, right? 110. This one was 88. And there we go. So then we end up with the positive and negatives, because this, if you look at that, it's then here we go. That's our D8, a C8 minus 90, and C9, F9. Oh yeah, here. F9, F8, and F9. So F8 and F9. So those are 110, there's our 88. And that's the actual thing. And then this is turning it into a decimal, and then this is subtracting the 90 degrees. So, and then there's the half tangent, 1/2 tangent radians, right, of this number here, this angle. And then we have these two added together. End up with that. That's our x squared. Write it down, but that's our a. 53.49 just comes right from that cell right there, C10. And then 800 is the incorrect. What do we have? 2991.65. So these here, I make it so that I can add information. I don't know if I changed this. Yeah, so everything else is locked except for the red ones. So that's our 29.91. It's not rounding up, because I can't change that now either because it's locked, but it's actually this number. And then it gives us this 20, 53, 29. So that's not 29.9. We're looking for 236.20. 236.2. Then we'll end up with 4 point. Copy that. Paste that. Copy that. Go back to iCAD. And we're going to do K. Looks like a double line to me. Oh. Let's take a look and see what the area is there. $29.90.4. So there's a little bust in there because of the these are rounded off. If you went and looked at these text way up, those aren't exactly accurate numbers. 26.12, but it's actually not exactly. So there you go. That's how you solve for that crazy closed traverse with multiple breaks. So that's how that's done. Close that. And there is more. I think I got into a lot. Oh yeah, if you wanted to get the area, that's how you would break down the area the other way. And then instead of using the shoelace. Now, that was the longest video yet, but it's a lot to handle, and I try to teach everything we learned up to and into it. So I think if you're interested in, I'm going to be doing some videos on center of gravity, probably not center of mass. We don't really do that, not point center of mass, but center of gravity for sure. So that's what the next video is probably going to be about. There's a lot I could do, but that's probably the next one that could, like I said, that knowing that could save your life, not overloading slings. So hope that helps you, and that's the end of the series. Good luck.